Hi everyone. Well, as we continue our series in exploring, optimizing, and designing for sustainability, we're continuing with the wind turbines for a little while longer, and you're going to be doing more and more of the work in predicting, at least that's the idea, and I should be doing less and less of it. This time we're going to pick some variables, and I of course I have to pick them for you, but in this case I'm going to pick not the number of blades, which was an obvious choice, but I'm going to pick the length of the blades because I have 7 and 9 inch blades, and I'm going to have 30, 45, and 60 degree angles, and then you're going to choose to, what you're going to do is you're going to plot each one. So you're going to get it says here plot an average power value for each modification, so I'm just making these 1 and not 2 because I'm not going to repeat them. So I'm confident in my own answers. And then this should be 9, sorry. So I'm going to switch between 7 and 9 inch blades, and then you will plot those and see how they're different. Try to do the 7 inch, one line for 7 inch and one line for 9 inch on each one, and try to see if there's something that you can that's better. It says what blade modification produced the greatest power output or the least, and you can say, oh, overall it was, which one was the highest of everything, and you can look and see, and then you can answer these questions on your own, and that's it. So this one says create a graph of average power versus a variable you tested. Pick one. You're going to pick either the blade length or the angle of the blade, and or you can do both. And anyway, let's get started. I'll record the data for you. All right, let's get started here. I'm going to collect, and this first run is going to be it's going to be 7 inch blades and 30 degree angle. So it should be going now, and it is. Hold on, right now it's going to go, and I'm going to turn the fan on. Let's see what we get here for a good head start. Gets up there pretty good, pretty quickly really, and so I'm going to stop it. I'm just going to stop and I'm just going to loosen this and increase the angle a little bit, because I can eyeball pretty good what 45 looks like. Having done this lots of times, I don't have to use the protractor. And then we're going to go ahead and tighten that up, and then do this again. See how our power does now. See, it should start increasing soon. Or did it not? It should be going. It is. Well, I think I'm missing one little here. There we go. Let's see how it goes. Let's hear it. So that's 45 degrees. And then I'm going to estimate 60 degrees. Let's do 60 degrees. All right, even steeper we're going to go here. We're going to go with. I can tell it's 60. There we go. There we go. Okay. It's just not going at all, really. It doesn't want to go. It's not having it. It's just basically nothing, essentially. Just because I'm curious, I'm now going to stop it for a second and go even flatter. Try it this way. See what it does. Very flat. This is about 15 degrees. That's just because I was curious. So I'm going to stop that now. And then I'm going to use my analytical tool here I'm going to highlight this area, this first one. These were 7-inch blades. And here I got an average of, I'm going to show this to you in a moment, of about 61 milliwatts. So I'll put the, it's 60.9. And then I'm going to highlight the second part here, which is going to be just right here. And I got 12.2 milliwatts. And then this last part, I got very little. Oh, that's right, that wasn't it. That's a mistake. It was actually here. It's next to nothing. I got about, the mean was 0.2, so basically nothing. And these are the values there. And then I will show you in a little bit we'll do the other ones here. What did I miss? 79, 79, 79. 7. Oh, I should have put this here, actually, sorry. I'll just save that quickly, and then give me a moment and I will do the other one. Okay, so we're now going to do the same thing with the 9-inch blades. And let's go ahead and try it out and see what we get. I'm going to push play here. And let's try it. This is the 30-degree one, so we're going to go ahead and run that out. And I am going to just stop it. I'm not going to stop the fan this time. I'm going to go with 45 degrees, which I'm pretty good estimating. I may have to fix that blade actually. And then I may have to get some extra cardboard here. So let's try this out. It is not, it's not having it. So that's very little. Now, I'm going to do even steeper. Let's see how we do. Okay. It's not going to be really anything. We've learned most of the air just rushes right past it. I think the answer for this one is 0 and 60 degrees. That's barely going. It's just this side is 0. Yeah, I need to fix that too. So that's that, and I'm going to stop this and we're going to analyze. First one is view statistics is 37.6. Then the second one is, second range is 3.8, and the third one is going to be pretty close to 0, I think. It is 0 point, yeah, it's 0, is going to call it 0. And I'm going to save that. Here's the data. Then I will come back and analyze it for you in a moment. All right, in this case, I put the data here. I put a run number, the pitch that we use, the blade length, and the power. And there's two different ways to look. There's no right or wrong way to look at this, so you're going to have to come up with your own. But in this case, I have the pitch, and the power is on the y-axis. This is the run number, and there's the blade length. And then you can look, there's another way to look at it here where I said the pitch is the x-axis down here. And then here's the power. As you know, we didn't really get a maximum. Well, you know, we could have, I mean, an experiment, something to think about is what if we had turned this down even more? What would the peak be, right? One question we haven't answered is what is the optimum angle, which is an important one to know because it just kind of goes down for us. That's great. That gives us a hint of where, and this is something for you to think about, like what experiments would you do to, you know, to find that. And in this case, we have the series 1 is the 7-inch blades. I should have made a legend here. I'll do that. I'll do that. So you can do that yourself. Series 1 is the 7-inch, and then series 2 is the 9-inch blades. And you can see for yourself what the trend is about the same. But appears that the 7-inch blades have more power, which is what we saw in our data. And all you have to do now is complete this lab, put your graphs in there, whichever one you pick. I just go in Command C, and for me, I just come over here and go, you know, Command V and paste it into the document. Whoops, gotta scoot it. It's behind this other chart here. Well, you get it. I don't want to play with it right now. Let's scoot this up. I can get this out of the way. But yeah, I don't want to ruin my stock document, so I'm not going to save that. However, that's what you do, and have a good time, and please turn that in. Thank you very much. Bye-bye.